The dangers of plaster renovation when the walls are wet and salty. Have you come across such facades? Aren't they ugly? Plastered a few years ago and now again damaged. Despite breathable restoration plaster, the moisture is rising. The obviously incorrect renovation measure cost a great deal of money, dirt and annoyance. This state worsens from one year to the next, as clearly demonstrated by the annual rings on these photographs. Do you think that could be changed? Yes. There is a remedy. You can do something about it. In this film we will show you a few tips and golden rules that will make things clear and dispel darkness. Mr. Mahorn is also a construction-oriented masonry diagnostician who has been performing research in this field from 1983 on and has developed a rapid measurement procedure for construction in order to work out the correct renovation techniques. Let's take a look at some of the scientific principles. Once these are understood, they will effectively resolve the problems encountered in practice. You are familiar with the substance we refer to as salt. Salt is able to strongly attract moisture from the air. This property is known as hygroscopic, from the Greek word hygros, which means moist, and skopin, which means to look. In a very dry indoor climate, salt trickles like fine sand. When the air becomes moister, salt turns stickier. Rule number 1, salt is very hygroscopic. When the horizontal isolation is damaged or absent in old masonry, ground moisture rises and takes salts with it. Salts in the ground are derived from the waste products of microorganisms. Fertilizers in the agriculture, road salts in winter, and of course from acid rain, atmospheric pollution. Most salts are deposited in the evaporation zone, or on the outer layers of the wall, which is the plaster. Salt concentrations are highest behind paint or wallpaper. This is the reason why paint or wallpaper appears to be moister when humidity is high and drier in the heating period. Salt attracts humidity. Rule 2. The higher the salt concentration on the wall surface, the more dangerous it is. Different salts have different hygroscopic properties. Ground salts like nitrates or chlorides attract moisture more than salts contained in building materials such as carbonates. The dangerousness of all harmful salts as well as their quantity can be determined directly and rapidly at the building site on the basis of their electrical conductivity. Time-consuming chemical analyses are not needed. Rule 3. The dangerousness of the total of the harming salts can be registered rapidly using measuring devices directly at the building. Once a certain level of salts has been achieved, the ONURM, Austrian standard, stipulates that effective measures must be taken. However, this fact is given too little attention in the building industry. Rule 4. A critical pollution level due to harmful salts calls for additional measures. To put it simply, a building specialist is obliged to check the level of salt pollution in masonry before any renovation of plaster, in order to initiate any measures that might be needed, such as partial desalination. As practice has shown, many so-called building or renovation specialists omit these critical, crucial examinations. Now, let's talk about plaster. Conventional plasters made of lime or cement, or both, dissolve salts from the brick surface, and they move then to the surface of the new plaster. This makes them unsuitable for masonry with critical levels of salts. Rule 5. Conventional plasters are unsuitable for masonry with excessive quantities of salt. On the one hand, so-called renovation plasters have a great property. Because of chemical additives, they are water repellent, known in technical jargon as hydrophobic, from Greek hydro water and phobic or phobos fear. This is very advantageous in the splashing water area. A simple test, the Aquapol hydrophobia test, shows the water repellent properties of the restoration plaster one has used. Distilled water, which is used for this purpose, is purified of salts and minerals and is not absorbed from the plaster. Here is a test with ordinary lime and cement plaster to make the difference clear. As you can see, the difference is enormous. Restoration plasters have a large percentage of pores. About 25% of the plaster volume must be air. Air pores provide the plaster with better thermal insulation properties than conventional plasters. Thanks to these very good properties, the open-pored and water-repellent renovation plaster does not permit any masonry moisture to pass in liquid form, but only in the form of vapour, which is humidity. Hence the plaster looks dry from the outside for a long time. But appearances are deceptive. The wall behind remains wet. Rule number 6. Renovation plaster alone, without drying out and without a horizontal moisture barrier, does not solve the problem. On the contrary, as building research as well as building practice have proven, moisture rises even higher and destroys the old plaster lying above. How does this happen? Well, the pores get clogged by salts. The initially open-pored renovation plaster becomes a waterproof plaster and thus locks up moisture. Rule number 7. Gradually, in the absence of drying out, a renovation render turns into a partly waterproof plaster. Now, what about masonry moisture? When should you ideally apply the new plaster? How long does it take for masonry to be dried out? Did you know that very moist masonry can absorb 400 to 500 litres of water per cubic metre? Try to make 1 litre of water evaporate on the stove. At the lowest setting, which would be the temperature of the sun, it would take several hours for moisture to evaporate fully. The sun will mainly absorb the uppermost layers. When should you start renovation of plaster when using conventional methods? The rules are very clear. After drying out. Why? Very simple. When moisture is evaporating through masonry, dissolved salts are transported as well. These would move into the new plaster and destroy it from the inside by clogging it. This usually takes about 3 to 6 years, depending upon the amount of moisture in masonry and the capillary head. Masonry moisture needs to evaporate completely through both sides of the wall. Rule number 8. Masonry should be dry before starting conventional plaster renovation. This is not the case when the Aquapol method is used. Only the upper part of masonry moisture evaporates. The much greater part moves downward into the porous capillary system of the wall. This reduces the drying out time by half. Dissolved salts come out in the upper evaporation zone and the larger part moves back to the ground where it came from. The evaporation phase takes about 3 to 12 months. You should ideally wait for this length of time before starting renovation of plaster. Rule number 9. When using the Aquapol procedure, you should ideally wait for the evaporation phase of partial desalination, which takes about 3 to 12 months, before renovating the plaster with a special technique. An old waterproof cement plaster should be removed as fast as possible. An open-pored lime cement plaster may be permitted to remain as a so-called victim plaster or salt buffer in the masonry. It will absorb the salts, which are then removed together with the old plaster. Rule number 10. The less salts there are in masonry, the less is the residual moisture. Even when masonry has partly been dried out and is supposed to be renovated with new plaster afterwards, you will have to pay attention to another factor: the pH value of the building materials. The pH value of a material tells you whether the material is an acid or a base, also known as lye. Water, for instance, has mainly a neutral pH value of about 7. Building materials have different pH values. The pH of brick, for instance, is about 7 or 8. Cement-based plaster has a pH of 13 to 14, thus it is highly alkaline. When materials of different pHs come together, as for instance brick and cement-based plaster, you will obtain a measurable electrochemical voltage between these materials. Rule number 11. Different moist materials connected with each other will generate electrochemical voltage. What does this mini power station or voltage or battery effect cause? It attracts moisture or retains it artificially. According to common parlance, cement attracts moisture. I understood this statement after examining the pH values of different materials. Different materials, especially when walls are slightly moist, create a positive pole in one material and a negative pole in the other, like a battery. This obviously results in a measurable voltage. The higher the pH differences between materials, the higher the voltage. Rule number 12. This electrochemical voltage attracts moisture and often keeps it in masonry. How does one avoid these conditions? How do we avoid these risks associated with salts and different pH values? How do we save time? Can one live in unplastered rooms for several years? Do you really have this much time? Does the thought disturb you? Can we plaster masonry faster without having to wait until it's dry? Does a fast and workable solution exist? A solution that uses natural resources and is biologically safe? Yes, it does. The intelligent Aquapole renovation technology.